Okay, going through these, just for those that have been out a chunk over the last couple weeks. I think I've gone through this once and posted. Can't remember. So we're going to go through it now. This is that extra set of notes. There's two sets of these that I put in your packet. This one deals with bonding. I can't remember what the other one is titled. But the covalent is the next chapter. So some of this I'll skip. Because we'll get into that when we get back from Christmas break. So nothing here is what we're looking at, but we are looking at ionic compounds. So just as review, okay, our chemical formula for an ionic compound gives us the ratio of cations to anions, so the positive to negative. It doesn't give us the exactly how many of anything. That's what you need to remember as we're going into this. To write the formula, we have to know which ions are involved and what their charges are. Okay, and we write the formula, we're trying to neutralize the charge because the formula is always neutral. Because that's why they bond, is to try to get rid of that charge. That charge gives them an instability. So here I have a 1 plus and a 1 minus. So if I just put those together, it's already neutral. So my formula is going to be NaF. Always put the positive first. Here I have a 2 plus and a 2 minus. So I just have BaO. Here I have a 1 plus and a 2 minus. So in order for that 1 plus sodium in order to have enough of it to neutralize the negative charge, I'm going to have 2. So I'm going to have Na2O. And here a 2 plus and a 1 minus, BaF2. Now there's this crisscross rule that works pretty much all the time with one caveat. So the charge on the cation becomes the subscript for the anion. And the charge on the anion becomes the subscript on the cation. Now, this caveat, this warning, is that we have to reduce to lowest terms. Because remember, this is supposed to represent not the actual number, it's just representing the ratio. So on this one, Al3 plus, aluminum, and then the oxygen. The 3 is going to become the subscript here, and the 2 will become the subscript there. So I have Al2O3. And just to double check, that gives me a total positive charge of 6 plus and a total negative charge of 6 minus. That gives me a total charge of 0. Now, the barium and the sulfur, if I just cross the charges, then I get Ba2S2. But that's not reduced to lowest terms. Okay, so I reduce this, end up with BAS. Okay, and also with the indium and bromine, the 3 and the 1. So INBR3. So there's formulas. Now, what if I have ionic polyatomics? It tells you your parentheses are required only when you need more than one bunch or more than one polyatomic. So here I have a 2 plus and 2 minus. Those charges cancel out. So I have BaSO4. This formula never changes. If it's sulfate, that's what you got. Mg and 1 minus. So I need 2 of this piece. That's where your parentheses come in. So I have Mg, open parentheses, NO2, close parentheses, 2. I can't say NO22 because that's not going to work anyways. Okay, so ammonium is a 1 plus, chlorate is a 1 minus, so I just write the whole thing down. NH4ClO3. Here I have a 4 plus and a 2 minus. So if we just cross the charges, then I ended up with a 2 here and a 4 there. That's not reduced to lowest term, so we reduce it and we get SN, open parentheses, SO4, 2. 3 plus, 2 minus, cross those charges, we end up with Fe2, open parentheses, Cr2O7, close parentheses, 3. Because this 3 applies to this whole thing. And then lastly, I have a 3- on the nitride and a 1+ on the ammonium. So open parentheses, NH4, 3N. Now, what about naming them? A little different. A couple of things. Single charge. So this is my groups 1 and 2 and 13. Group 1 always is 1+, group 2 is always 2+, group 3 is always 13+. And that's also silver is always a 1+, and zinc is always a 2+. So if I am given the formula and I need to name it, I give the name of the cation and then the name of the anion with that IDE ending. That's it. That's all there is to it. So my cation here is sodium. And then the anion is fluoride. Cation is barium. Anion is oxide. That's it. There's nothing special to these. Na2, it's still sodium. The name doesn't have anything to do with how many there are. So this is sodium oxide. Now, if I'm given the name and I need to get back to the formula, again, I write the symbols for the 2. So I have silver and it's a 1+. Sulfide and it's a 2-. Balance the charges to figure out my formula. So Ag2S. Zinc is a 2+. Phosphide is a 3-. So Zn3P2. Nothing special. And then, oops, I hit a button. Now, what about my multi-charge? There's a couple of different ways that we have to look at this. My multi-charge cations are my whole D block, with the exception of silver and zinc. And then I also have lead, which could be a 2+ or a 4+. And I have tin, that can be a 2+ or a 4+. So those are my multi-charge. So I have to figure out the charge of the cation. So the way we do that is if I crossed my charges to find out my subscripts, then I should be able to take those subscripts and uncross those to figure my charges. That's step 1. So if I do that here, then I have a 1+ and a 1-. Well, to check it, I have to check by the anion because there are no multi-charge anions. Is oxygen a 1- ion? It's not. So that means this formula was reduced. So I'm going to double both of these so that I get to the correct charge on the oxide. So that means this is iron 2, because that's my thing. I have to write in Roman numerals to show me my cation's charge, and then oxide. So here, if I uncross, I have a 3+ and a 2-. And yes, oxide is a 2-. I don't have to reduce or unreduce anything. So this is iron 3 oxide. Okay. Now, if I'm given the name, then I already know the charge. I know this is cobalt 3, so this is a 3+. This is a 1-, so this is COCl3. Tin 4 means this is a 4+. And this is a 2-. So if I just cross my charges, I'm going to have SN2O4. But remember, I have to reduce that. So this becomes SNO2. And then tin 2 means this is a 2+. This is a 2-, so it's just SNO. Now, we also have these polyatomics. The same rules apply as before. I just named the cation and named the anion. So if I need to write the formula, iron 3 means this is a 3+. Nitrite is on your list of polyatomics, so it's NO2, 1-. So iron, open parentheses, NO2, close parentheses, 3, because this 3 becomes the subscript out there. Now, ammonium is a 1+ charge. Phosphide is a 3-. So that means I only need 3 of this. So open parentheses, NH4, close parentheses, 3, and then the P for the phosphide. Now, if I'm asked to give the names, then I have to figure out what's first. Well, this one's easy because NH4 we know is a polyatomic. So I have ammonium, And this is thiosulfate. It's on your list. Now, I told them in class you're either going to have a polyatomic, hydrogen, or a metal first. Well, this time I have a metal first. So this is silver. And then the rest of it's going to be on your list. So it's bromate. You're never going to give me more than 2 words. Okay. Now, the first word may have a Roman numeral attached, but you're never going to give me more than 2 words to name a compound. So here I have ammonium again. Nitride. Now, traditional system, and we did one worksheet with this. If you look at that list of polyatomic ions on the right-hand column, it's your multi-charge cations. So the ones that have 2 charges, these are our most common. These are the oldest elements that were known to have charges. And so for the traditional, the old way of naming them, we use their Latin root and then an ending, either IC or OUS, depending on which charge it has. So if you have cuprous sulfide, that's copper as a 1+ charge. Sulfide is still 2-, so this is Cu2S. That's all that is. Auric nitride, that's going to be gold with the 3+. Nitride is a 3-. This is going to be AUN. Now, to write the names, I have to do the same thing I was doing before. I uncross the charges to figure out what uncross the subscripts to figure out charges. So 4+ and 3-. Phosphide is a 3-. So PB is lead. So plum. The 4+ is your higher charge. And then phosphide. I think that's it that I can show you on this.